What do you mean by proportion then? A proportion is nothing but the equality of two ratios. If the value of B is equal to the square root of AC, that is square root of the extremes, then we say the given proportion is a mean proportion. And simple proportion means the number of related terms always remains only 4. What do you mean by direct proportion? So it is the correlation between the terms inside the proportion. Hello everyone, a warm welcome to one and all. This is Shruti, lecturing in Vidhyaashram, the Temple of Excellence, Mysore. So welcome to the fourth session of the chapter Ratios and Proportion. In our previous session, we have discussed the concepts of ratios, also important problems on 2 marks, 3 marks and 5 marks for your examination. From this session, we will be learning about proportions. So in today's session, we will be discussing about the concept of proportions and the types of proportion and the properties of proportion. So let us study them one by one. What do you mean by proportion then? A proportion is nothing but the equality of two ratios. What do you mean by ratio? A ratio is the relationship between two or more quantities of same kind. And the equality of two ratios is nothing but proportion. Suppose you have two ratios, A is to B and C is to D. So the equality, so you equate this is equal to C is to D. This is nothing but proportion, and this is replaced by proportionality symbol. And it is usually written in the form of A is to B proportional to C is to D. This is nothing but when you write this in the fraction form, it is A by B is equal to C by D. So you can also cross multiply, that is AD is equal to BC. So this is the condition of a proportionalities. That is, we call AD as extremes and BC as means. So the product of AD must be equal to product of BC. Then only we say they are in proportion. For example, I have taken the ratio 2 is to 3 and 6 is to 9 here. So to say that 2, 3, 6 and 9 are in proportion, let us write 2 is to 3 proportional to 6 is to 9. So the product of the extremes, that is 2 into 9, and the product of means, that is 3 into 6, must be equal to 18. So if the product of means and product of extremes are equal, we say the given ratios are in proportion. So let us see, or let us take an example now. So state which of the following are in proportions. We have one example here, 1 is to 3 proportional to 4 is to 15. Let us see the product of extreme, that is 1 into 15 is equal to 15. 3 is to 4, that is 3 into 4 is equal to 12. So 1 into 5 is not equal to 3 into 4 because therefore we say they are not in proportion. Whereas in the previous case you can see the product of extremes was equal to the product of means, therefore they are in the proportion. But here their product is not equal, so therefore they are not proportion. Next, we will study different types of proportions. So the first one is mean proportion. What do you mean by this mean proportion? Now we have 3 terms, that is A, B, C, are said to be in mean proportion if A is to B is proportional to B is to C. That is, the means are same here. That is nothing but A into C must be equal to B into B, or we can write this as B square is equal to AC, or B is equal to root of AC. If the value of B is equal to the square root of AC, that is square root of the extremes, then we say the given proportion is a mean proportion. I have taken an example of 139 here. So let us write first this in terms of mean proportion. How we will write? 1 is to 3 proportional to 3 is to 9. So what is the value of A here? A into C, that is A into C is 9. What is B square here? B square is also 9. But what is B? B is equal to 3. So this is nothing but root of AC, which is equal to root of 9, that is equal to 3. So the value of B is 3, which is nothing but root of AC. So that is, if B square is equal to AC or B is equal to root of AC, that is the value of mean is the square root of extremes, then we say it is a mean proportion. Next, we have simple proportion. A simple proportion contains only 4 terms, that is A, B, C, D, and we have write it in the form of A is to B proportional to C is to D. For example, 2 is to 3 proportional to 8 is to 12. Here also you can see 12 2s are 24, 3 8s are 24. The product of extremes is equal to the product of means they are in proportion. And simple proportion means the number of related terms always remains only 4. So you can count the related terms 1, 2, 3, 4. So you have only 4 related terms. Then we call it as a simple proportion. Next, compound proportion. What do you mean by compound proportion? If the number of terms is more than 4, we call it as a compound proportion. So how you have learnt a compound ratio, that is multiple of 2 or more ratio will give rise to the compound ratio. Similarly, you have a compound proportion here also, that is we are equating more than 2 ratios. So you can see here 2 is to 3 proportional to 8 is to 12 proportional to 6 is to 9. So these type of proportion, when the proportion terms exceeds 4, we call it as a compound proportion. Similarly, we have a continued proportion. Here, the number of ratios exceeds, goes on exceeding. That is, for example, you can see A is to A, B is to B, C is to C, D is to D, and so on. So similarly, here you can see 1 is to 2, 2 is to 4, 8 is to 16, and we can write few more ratios to make them equal. So these type of proportions are called as continued proportions. Next, we have direct proportion. What do you mean by direct proportion? So it is the correlation between the terms inside the proportion. So whenever you are relating on, whenever you are equating 2 ratios, the quantity of one, if increasing, the quantity of other is also increasing. Or if the quantity of one is decreasing, the quantity of the other ratio is also decreasing. That means, so it is a positive correlation between the related terms. When there is an increase in the value of one followed by proportionate increase in the value of another. And similarly, if there is a decrease in value of one, then there will be a decrease in the value of another. So these type of proportions are called as direct proportion. Here we have an example. The ratio between cost and quantity of articles. Suppose if you have 10 rupees and you will buy 2 pens. If you have 20 rupees, you will buy 4 pens. As the cost increases, number of articles increases. As the cost decreases, number of article decreases. So that is what the corresponding value of one increases, then proportionally the corresponding value of other also increases. Similarly, if the corresponding value of one decreases, the proportional value of the other also decreases. Those type of proportions are called as direct proportions. One more example we have here, the height and weight of the person. As you grow up, your weight also increases. So this is an examples for direct proportions. Next, we have inverse proportion. As the name itself says, if the quantity of one value increases and the proportional value of the other decreases. Similarly, if the quantity of one value decreases, the proportional value of the other increases. So, this combinations of ratios as proportion is called as inverse proportion. Here we have examples for inverse proportion. The ratio between the number of workers and the amount of time. Suppose I'll say 2 person finishes works in 10 hours. Suppose I have 10 workers. What about the number of hours or amount of time here? It decreases. So what happens here, as the number of person is increasing, the amount of time is decreasing. So this is an example of inverse proportion. Next we have the ratio of supply and price. So as the more supply you will get, the price of the supplies also increases. So these examples we can take as an inverse proportion. Next we have some properties on proportion. The very first property is called as invertendo. What do you mean by invertendo? If we have a proportion in this form, A is to B is equal to C is to D, then the inverse of ratio, if A is to B is a ratio, the inverse of this ratio is B is to A, and C is to D is the ratio, the inverse of that ratio is C is to D. And if you write that in a proportionality form, it is B is to A is equal to D is to C. So this property of writing the proportion is called as invertendo. How we will get this? You can see. So if I have A is to B is equal to C is to D, if I write this in fraction form, A by B is equal to C by D. So if you want the reverse of this ratio, then it is B by A is equal to D by C. So write it again. This is B by A is equal to D is to C. So this is what the invertendo, that is the inverse of the proportions given. Next we have alternando. So what is this alternando? So that is, if you have a ratio A is to B is equal to C is to D, then the ratio with A and C and B and D is called as, writing the ratio in this form is called as alternando. How we will get this? We have a proof. Suppose we have A by B is equal to C by D. What I am supposed to do? I will multiply B by C here. Similarly, I will multiply the same thing. So in equality, you are supposed to multiply the same quantity. So here B get cancels, I will get A by C. Here C get cancels, I will write B by D. If you write this, you will get A is to C is equal to B is to D. So writing the given proportion in this form, A is to C is equal to B is to D, is called as alternando. Next we have componendo. So what is componendo? If you have a proportion A is to B is equal to C is to D, then A plus B is to B, C plus D is to D. That is, if you write in fraction form, you will get A plus B by B is equal to C plus D by D. How you will get this? We have a ratio A is to B is equal to C is to D. That is A by B, C by D. Add +1 to both sides. What happens when you take fraction? It is A plus B by B, which is equal to C plus D by D. If you write this in the proportional form, A plus B is to B proportional to C plus D is to D. So this is what the componendo. Next we have dividendo. So according to this property, if you have a ratio A is to B is equal to C is to D, then this form A minus B by A, C minus D by D. So that is here A by B, here we have C by D. Subtract 1 on both sides and take the LCM. So you will get this form. Again you can write this in the form of proportionality. So this is called as dividendo. Next we have componendo and dividendo. That is, this is the proportional you have given. So taking componendo, that is, after adding 1 for the given ratio, we will get this equation. And similarly, after subtracting 1, we will get this equation. That is equation 2. So dividing both equation 1 and equation 2, denominator BB and DD get cancelled. We will get this one. This is, we call it as both componendo and dividendo. So writing the proportional 4 terms, that is A is to B proportional to C is to D in this form, that is A plus B by A minus B, C plus D by C minus D, is called as componendo and dividendo. All these properties helps to solve problems in terms of proportions. So we'll take simple problems now. Find the fourth proportional of 6, 14, 15. So fourth proportional means suppose you have 4 terms. So this is first, second, third and fourth proportion. I doesn't know the value of fourth proportion. I have only 3 terms, that is 6, 14 and 15. So let me write this. 6 is to 14 proportional to 15 is to x. So when you say the given ratios are in proportional, when the product of extremes is equal to the product of means. So let me take it. So that is 6 into x, 6x is equal to 14 into 15. So if you write this, x is equal to 14 into 15 divided by 6. So we have 3 5s are, 3 3s are. So that is 70 divided by 3. So the value of x is 70 divided by 3. Let's take few problems on proportional, that is to find an unknown value in the proportion. Now find the fourth proportional of 6, 14 and 15. Suppose you have 2 ratios in proportional, that is C is to D. When we say that they are in proportion, they are in proportion if the product of extremes is equal to product of means, that is AD is equal to BC. So using this concept we will solve, but we doesn't know the value of the fourth variable. So we will take the value as x. So 6 is to 14, proportionality to 15 is to x. Since I have to find the fourth proportional, I am taking the fourth value as x. Now what is product of extremes? 6 into x, that is equal to 14 into 15. So x is equal to 14 into 15 divided by 6. 3 5s are, 3 2s are, 2 1s are, 2 7s are. Therefore x is equal to 35. So this is the value of the fourth proportional. Next we have 1.5, 4.5, 3.5. So that is 1.5 is to 4.5 proportional to 3.5 is to x. So when you multiply you will get 1.5 x is equal to 4.5 into 3.5, or x is equal to 4.5 into 3.5 divided by 1.5. So you can divide this 1s are, 3s are, and when you multiply you will get x is equal to 10.5. So this is the value of the fourth proportional. Find the mean proportional of 9 and 16. What do you mean by proportional? In the mean proportional you have only 3 terms, that is A, B and C. We will write in this form B is to C, that is means are same. Therefore to find mean you should take the value of B as x. If you write this in the form of mean proportional, you will get it as 9 is to x proportional to x is to 16. That is, the value of extremes are given. We have to find the mean. So what is the condition for this? What is the product of extremes? A into C. Here it is B square. So we can take B is equal to root of AC. When you apply this condition here, you will get it as x is equal to square root of 9 into 16. That is, x is equal to square root of 144. X is equal to 12 you will get. Find the mean proportional of 2 and 8. So that is 2 is to x proportional to x is to 8. So x is equal to, so that is x square is equal to 2 into 8 you will get, or x is equal to square root of 2 8. So remember you can directly put B is equal to A into C. That is, you want B, then you should take the square root of extremes. So x is equal to root of 16. So x is equal to 4. Next we have find the third proportional of 6 and 24. So what do you mean by this third proportional? Third proportional means you have first and second. So the third, in the ratio you will be having 4 terms. So that is A, B, C and D. Now I have to find the third. But what about the fourth one? Here they have given only 2 terms. So therefore the third proportional means it is nothing but a mean proportional, but you are finding the third one. That is, you have one extreme along with mean and this one is unknown. So you are going to find the C. So if I write this in the form of third proportional, this is 6 is to 24, 24 is to x. So this is your first proportional, second proportional and the third proportional. The third proportional means you should write this in the form of mean proportion. Now, what is the product of extremes? 6x. So this is 24 into 24. X is equal to 24 into 24 divided by 6. 6 ones are, 6 fours are. So x is equal to 96. Next we have one more problem, 3 and 12. So this is 3, 12, 12x. So product of extremes, 3x, product of means, 12 into 12. So x is equal to 12 into 12 divided by 3. 3 ones are, 3 fours are, x is equal to 48. So this is your third proportional. So in this class we have studied what do you mean by proportion, their types and simple problems to find the mean proportional, fourth proportional and the third proportional. These type of question will carry 1 marks in your examination, and the properties of proportion. We'll solve few problems on properties of proportion in our next session along with few application problems and proportions. Until then, keep watching, keep learning and keep exploring. Thank you.